We were sitting on stage, I know.
Oh,
yes.
Welcome to All Space Considered, everybody. I'm Dr. David Reitzel, and it is the third Thursday of the month, and All Space Considered. No, it's the third. Well, it's the fourth, but it's.
But it's also the third.
Yeah. I was getting to that. Our show is every third Thursday of the month, except when it's not, like tonight. Every once in a while, we get bumped. Things happen. There was a rental. I don't know if you saw it, but it was a big announcement by FIFA about the branding of the launch of the next World Cup that happened here at Griffith Observatory. It was kind of spectacular. People could watch it streaming. I was told nothing about it other than we have to move All Space Considered. So third Thursday of the month, fourth Thursday of the month, or anyway. But most of the time you can count on us being the third, even though today isn't. We do have a great show with us, or for you tonight, and maybe I need to turn it on. That always helps. Today's May 25th, and Solar System Stampede is the theme of the show, or the primary theme. We're going to talk about JWST looking locally, how Sodium, Gemini, and 3200 Phaethon have something to do with one another. Juno's 51st, Juicy Story, Years Ago Today on Venus, and Lick Observatory Wants Goats. That's going to be the first half of our show. Then we're going to, Sky Report will kind of be in the first half too, because we'll take a short break, just a couple of minute, 2-3 minute long video, and we'll let folks stretch their legs a little bit, so you can plan on that, but it's not a long break. Then we'll come back to Out to Launch, Amazing Mars, and then we're going to dive out to deep space briefly, just because we needed a little deep space stuff in the show as well after all that solar system. But like I was saying, I'm Dr. David Reitzel, and tonight is All Space Considered. And All Space Considered is brought to you by the Department of Recreation and Parks in the city of Los Angeles. Griffith Observatory is owned and operated by the city of LA. And we do like to thank Griffith Observatory Foundation, who is our exclusive nonprofit partner. So we thank all of them out there. And for everybody out there watching us on YouTube, hello. Thanks so much. We'll find a way to get back to your questions again. Right now, we don't have any way to answer your questions live, but we'll return to that at some point. Tonight, I want to introduce our panel and introduce to you Vanessa, who is joining us here at All Space Considered. We're very excited. Vanessa is an emergency appointment for the Astronomical Observer position. So that's the position formerly held by Tony Cook, and Vanessa is here to, take care of our telescopes, take care of the staff, make sure that we are here to serve the public the way we always did, make sure everything's working. And then as we go through the process to find a permanent replacement, we'll see what happens from there. But I'm thrilled to have Vanessa here, both to help us with our telescopes, but also on stage tonight. So welcome.
Thank you.
Let's give her a round of applause. And also, of course, Chris Butler is here, wonderful Patrick So, as always, and Jared Head is joining us on stage too. So got a wonderful show for everybody tonight. I think that's all the business we need to cover, I believe. We may as well just launch right into this. Making sure I have it on. I do still. There we go. JWST, our beautiful telescope out at L1. Indeed, all of those are segmented mirrors. That thing was folded up. You've heard all about that. And you've seen lots of deep space observations from it. Galaxies, clusters, gravitational arcs. Well, it also observed a comet in the asteroid belt. Asteroid belt comet? What are you talking about? I thought those were out in the Kuiper belt or out in the Oort cloud. Well, no, it turns out that there are actually some objects in the asteroid belt that actually kind of give off a coma and have a little bit of a tail as well. And they pointed JWST at it, and they got a spectrum. And it turns out, indeed, that little bit of a coma around it is water. It's water vapor around it. Mm-hmm. So it is ice that's being sublimed somehow. Now, the odd thing was, this comet red, I don't think it's Reed. I think maybe it's red. Anyway, a little different. You can see Comet Hartley there is the blue spectrum. Well, you see carbon dioxide there. Why this one in the asteroid belt has no carbon dioxide is interesting. Perhaps because it's closer to the sun, all the CO2 maybe has sublimed away, so maybe it's gone, maybe it had it before. So a little bit different than what you'd see there. So Webb has made a discovery there. By the way, you see the sign Deep Impact there. That was another mission that did smash into the comet. So we've done that before. And here's a beautiful picture of that comet. JWST was also used to observe this solar system object, and that indeed is the planet Uranus, and those are Uranus's moons and rings. You can see it up close there, just gorgeous shot of those rings.
Yeah, beautiful.
You know, so we have many ringed planets in our solar system, which is quite exciting. Label the rings here for you. The clouds, the polar cap, the zeta ring, which is that inner ring that I'm not sure was well documented before. So certainly some new information from Uranus. And then lastly, its pole is pointed towards us right now and has been for a while. And they've been making radio observations, and they put together their data, and it turns out there is a warm spot right below the pole, and they think it has to do with a cyclone. That little very bright spot right at the very, very tippy top of the pole is that cyclone they think that's, you know, swirling away down underneath those top cloud layers. So there's a storm at the pole of Uranus. The Geminid meteor showers. This is actually a picture of a meteor shower. You leave your camera open for a period of time. This is probably, I don't know, a couple of hours, and then they have to expose the foreground briefly so that the stars don't, anyway. There's a trick to doing it where you don't get star trails, just so you know. You have to track the stars. Anyway, long story short, they all appear to be coming from one direction. That's because this is a meteor shower. This debris is moving around in sort of a stream out there, and our orbit, the Earth's orbit, happens to be crossing that stream. The Geminids were learned to be caused by an asteroid called Phaethon, which is a little weird because normally meteor showers are caused by comets. The debris coming off of a comet, the little grains of sand that gets left behind in the orbit, leave a trail. Well, this is an asteroid that had an orbit that matched the orbit of the little particles that caused the Geminids. So that was very, very weird. People thought, well, how can that be? Well, this is a radar observation from Arecibo, back when Arecibo was functional. Looks pretty smooth to me. I'm not seeing a lot of craters on the object. I'm not seeing any strange shape to it. It's not shaped like a peanut. Okay, but people said, well, maybe fizzling sodium could explain its comet-like activity and also maybe the little bit of dust that's coming off. We saw that every time it got near the sun, you'd see a little tail show up. And they thought, well, that's the dust tail. It's the dust being thrown off, and that's what's forming the meteors. Well, the meteoroids that later become meteors when they travel through our atmosphere. But folks said, well, how do you get the dust out there? And he said, well, if there's sodium in this, the sodium will get hot enough that it'll vaporize, and that'll blow the dust out into space. Well, they went and looked, and by the way, sodium is what those orange streetlights are made out of. So if it's sodium that's vaporizing, you'd expect to see an orange glow around 3200 Phaethon when it was near the sun. So indeed, that's what they did. They used the Soho Observatory, and in orange light, you can see right there, beautiful glow. In blue light, nothing. The blue light is where the dust should be. Well, why is there no dust? If it's the dust being blown off by the sodium causing this meteor shower, you'd expect to see dust, and we're not. So that was a little bit weird. They did some models, and the models seemed to indicate the rate at which the sodium was coming off, at least right now, is not enough to put all that dust out there that's needed for the meteor shower. That doesn't say in the past it wasn't enough, or that it didn't have some sort of major event 1,000 years ago. Maybe a cliff collapsed on it. And also, this is the cool one, Phaethon is spinning rapidly. It's spinning so rapidly that stuff on the equator is barely bound. You know, it's kind of like if you're whipping around a thing on a string. If that string breaks, the thing's going to go flying off. Well, the gravity is what's holding it in there. So all it takes is a little extra force and the stuff comes off. So maybe the sodium doesn't have as much of a barrier since it's spinning so quickly. So interesting object, very, very strange. And by the way, they put together these pictures -3 days before its closest approach to the sun. At 0, that's the perihelion, the closest approach, and then 3 days after, and you can see that tail grow. It's faint, but you can just make it out as you can see it get longer and longer and longer. So sodium tail. By the way, this is a different kind of sodium than the salt you put in your like water when you're cooking pasta. So that's NaCl, that's sodium chloride. This is just plain sodium, and when you put it in water, it kind of catches on fire and explodes. So you don't want to cook your pasta with it.
Not
a
pasta
good idea.
friendly.
Well, you could cook it once.
Yeah.
Just once, just once. So, so that's your couple of web stories. JWST has been observing the solar system, as you've known, and results are coming out. So some pretty cool stuff. Now we're going to turn to Patrick and Juno and find out what Juno's been up to.
Okay, let's go to this slide here. Well, Juno is NASA's mission to explore Jupiter. And there's a spacecraft that's been going around Jupiter since 2016. It's actually got captured in orbit on July 4th. And on April 8th, Juno went around Jupiter for the 50th time, did a close pass of it. And we have a celebration of its close passage, and all the images it's taken since it first was captured around Jupiter and is now in a captured orbit to explore our gas giant. Just to give you an idea of the Juno spacecraft, it is a huge spacecraft. You can see it's person to scale. Has these large solar panels, and that's because it's at Jupiter. Jupiter receives 25 times less light than we receive compared to Earth. So it needs these large solar panels to generate the electrical power to power all of its 6 instruments, which are dedicated to unraveling some of the properties of Jupiter's, especially the interior of Jupiter, its atmosphere, its fields and particles surrounding it. It also carries a Juno cam, which is responsible for sending back some of the most spectacular images of Jupiter, and you can see it's indicated in that little box there, and with an arrow pointing to that tiny camera that's just sticking outside the container, which is actually a titanium container, because all the instruments are electronic and they have to be protected as Juno orbits Jupiter. It takes it far from Jupiter, and then when it gets close, it has to duck in under the intense radiation belt. So when it makes a close flyby, that is called a perijove, and since April 8th, we've moved on to one more perijove, which is now the 51st perijove of Jupiter, which occurred on May 16th. And as that perijove point is where the arrow is indicated, is the closest portion of its flight path, where it gets as close as 2,000 miles just above the cloud tops of Jupiter. And it's moving at 140,000 miles per hour. Now, one of the interesting things about this flight path, it is orientated such that right now, the flight path is lined up to Jupiter's terminator, which is a line that divides day and night on Jupiter. And as such, when Juno approaches Jupiter, we get these incredible pictures that we can't see from a vantage point of the Earth, because Jupiter is always full, because it's on its outside orbit from us. But we can see that we get this image of a gibbous Jupiter, which we can never see from Earth. Going to the next image, Juno has a polar orbit, so it goes over the North Pole first and goes around the planet, across the equator, and goes underneath the South Pole, and then on its way out. And the whole journey takes about 2 hours, and during this perijove kind of encounter, all the instruments are operating and gathering lots of data. So we're going to take a look at some pictures from perijove 51, as in this next one. When the spacecraft flies over the pole, we get this. We see here some northern circumpolar cyclones. And there are actually 8 of them going around the North Pole of Jupiter. And you can see they're actually surrounding one central cyclone. And if I can get my laser pointer here. These are the ones. The other ones are in shadow, so there's supposed to be 8 of them. And this is the North Pole region, this part here of Jupiter. So that's an incredible sight. Each of these cyclones are roughly about the size of the United States. And here's another image, all color enhanced by citizen scientists, because the images come in and they look very pale. People, they get posted onto the Juno site, and anyone could download them, use Photoshop or some other photo processing, yes, thank you. And they can actually bring out some of the details and color enhance these images. Okay, so not only is Jupiter being photographed by Juno, but during Juno's extended mission, the Juno spacecraft had the opportunity to fly by three of its largest Galilean moons. One is Ganymede, which was on perigeo 34, and the other was Europa. On this perigeo, Juno got a chance to fly close to the moon Io, which is Jupiter's innermost moon, and it's one of the most volcanically active moons. And it's been getting closer on every flyby since perigeo 41. And you can see the distance decreasing, and the image is getting, resolution is getting increasing as well. So on the last one, it was perigeo 49. Juno got as close as 32,000 miles. On this one, it is 23,000 miles roughly, and so we got this spectacular image of Io, which is basically a moon covered with lava fields and
pepperonis.
Yeah, pepperoni or whatever. Yes.
Just saying.
The meat planet.
Yes, indeed.
It's melty.
Now this isn't as close as the next image. The closest image was just 22,000 miles, which was like 900 miles closer. So this is so far from Juno the closest image that we've had of Io. Now we're not done with Io yet, because there's going to be two even closer flybys of Io, and that's occurring at the end of the year, December 30th, and then the beginning of February of 2024. And the spacecraft will fly as close as 1,500 kilometers, or about 930 miles above Io's surface. And I'm sure that we'll get some really spectacular pictures, and maybe we'll catch some volcanoes exploding in the process there. Now, there are so many images posted, or actually posted on the website of the mission Juno, and you can see some of those spectacular images, not only of the polar regions, but also of the equatorial regions, temperate regions of Jupiter, with really spectacular swirling storms and pop-up thunderstorm type of cumulus clouds. And you can see all of that at this site. So if you happen to go on the site, take a look at all the images that have been sent back by Juno so far.
Wow, thank you, Patrick. Yeah, the processing people do on these images to bring out detail is really fun. People really got behind it when it first arrived, and I have a feeling that they might go crazy with that close flyby of Io. We're going to have some really great stuff come out of it. Well, there is another mission on the way to Jupiter right now called JWST. This is an artist's rendition of the JWST spacecraft that's out there. It's on its way. It had a little bit of trouble with an antenna. They had to jiggle it to get it deployed. And by the way, it's a mission headed to go study the icy moons of Jupiter. Our very own Daniel Perea, one of our producers and a museum guide here at Griffith Observatory, is also a student up at Santa Cruz, and one of his professors up there is involved with the mission, and he got a chance to talk to him about it. So we recorded a little segment. This is only about a minute of it, and we're going to post the full interview to our YouTube channel. So if you're interested in seeing the entire interview, which is about 10 minutes long, you can check it out on our YouTube channels. But here's a little teaser about what JWST is going to be doing.
Today, I have the esteemed honor of being joined by Professor Francis Nimmo. How are you today?
I'm doing well, thank you.
this object at the center of our discussion today is the European Space Agency's recently launched Jupiter Icy Moons Explorer. What, in your opinion, makes JUICE significant to our study of Jupiter and its icy moons?
So JUICE is going to do something that has never been done before, go into orbit round one of these icy moons. We'll actually be able to see some way inside the ice shell, which is, again, something that's never been attempted before. And then it will measure the magnetic field around Ganymede. And Ganymede's magnetic field is actually very complicated, like the Earth's magnetic field.
Could you actually discuss some of the challenges that the JUICE mission may face, or maybe even has faced already?
Ground penetrating radar failed to deploy. They shook it up enough that now that radar boom has deployed, and so that was a problem, but they seem to have managed to fix it, and the spacecraft, I think, is now quite happy.
Yes.
Yeah, quite happy. We always personify spacecraft, but make sure you check out the full interview on our YouTube channel. We're going to post that there for you, and exciting once it gets there to learn a lot more about these icy moons. All right, well, Chris, we're going to turn to you right now, and
I want to talk about Venus. Okay, give me just a second. I'll talk about Venus, but I want to say that story about JUICE and what happened with it. I went through past traumatic stress on this because in 1989 I was working on the space shuttle program for Rockwell International, and we had just launched Atlantis on STS-34 to launch our good friend off to Jupiter, right? And the Galileo mission. And they had the antenna stick. Yeah, part like an umbrella, part way open. And it was so agonizing for all of us. We were just like, to come all this way. And I swear, and we're just like, if you had an astronaut, they could just grab it and fix it. And this was it, like it's going to happen again. Jupiter has a curse. Fortunately, no, right? Everything's fine now. So whew, I feel so much better. This is going to be a great mission. So I just had to get that off my chest. Sorry. Okay, as far as me, talking about years ago today, our history segment, and talking about Venus, I don't know if we have a lot of amateur astronomers in the audience with us this evening, but I've spent a long time with telescopes looking at Venus. And Venus is wonderful but elusive, and our relationship with it has been this way all along, and it still is today. Venus is the brightest thing in the sky except for the sun and the moon. It has been visible throughout history and prehistory and all the rest of this. The dinosaurs, no doubt, had no trouble seeing this, although I don't think they understood what it was. Hey, don't knock it. If they'd known more about what was going on in astronomy, the situation might have been different later for them. But with Venus, looking at it in the sky, it is so easy, but there are things throughout history that have remained kind of elusive. For example, in ancient Greece, you go back to a time like here's Aristotle or something. No, it's actually Socrates. He's having something to drink that he shouldn't. These folks in ancient Greece, they had all kinds of philosophy about the shape of the universe and how things worked. But something that Venus did confused some of them for a while, and some early cultures around the world, in fact. What Venus will do, it's the next planet inside. It's on orbit number 2, and we're on number 3. So its motions look rather like this if you plot it over many, many, many weeks and months and so forth. Venus will be far away, be back behind the sun, and then it will catch up to us, moving faster on its inside orbit, swing out away from the sun. You'll see it hanging there for quite a while, as it is right now. There's a reason I'm mentioning Venus. It's brilliant in the evening sky, right? So you want to have a look at this. And then it will dive down between us and the sun, and it will disappear. But then if you wait a week or two, you'll see it in the morning sky. And it will appear, it will leap up out of the dawn over several weeks, and then suddenly it'll be bright, and then you'll see it in the morning sky. So you have the evening star, which people would call this brilliant object, and the morning star. And for a while, people did think they were two different gods or planets, depending on what you wanted to say about them. The Greeks in particular thought that Hesperus was the evening star, and that Phosphorus was the morning star. There were a number of cultures who regarded this as being two different objects entirely. but even though they looked just the same, and one of them would conveniently disappear when the other one appeared. We're talking Clark Kent and Superman here. This is not a tough mystery to figure out. Clark always excuses himself, ducks out, and Superman shows up. So eventually they did figure out that this was indeed one object, the planet we now know today as Venus. Venus was incredibly important for this epochal discovery. You guys probably know that Galileo, observing Venus with the first practical astronomical telescope in 1610, figured out absolutely that the Copernican model of the universe, where the sun was at the center, was accurate, and the old Ptolemaic system, which had been long accepted, where the Earth was at the center, was not so. Well, without getting into the details of how the two systems work, the Ptolemaic system had Venus closer to the Earth than the sun. It would always be closer to it. And Venus, while doing a circle, this orbiting sort of motion, was orbiting around an empty space. It was not orbiting the sun at all. And that's the top view that you see there. And as you can see, if you looked at Venus and it was a non-luminous object, we didn't know that, by the way, until Galileo looked at it. We see it, it's a ball, and it's being lit by something. It's being lit by the sun. The sun is obviously luminous. In the Ptolemaic system, it will always be a crescent, always, because the sun is farther away. So Galileo, when he looked at Venus, and he saw that we went through all the phases that, for example, our moon does. Sometimes it's full when it's back and it's farther away than the sun, fully illuminated, and then half illuminated, then swinging through a crescent. There was only one way this could happen, and that was if Venus orbited the sun. That's why this was such an epic discovery. Can you imagine being the only person in the world who knew? I've always thought this about Galileo. That night where you went, I'm the only guy who knows. And then, of course, what they do, put him on house arrest, right? But he did indeed prove that the sun was the center. So it's bright, easy to find. You have a telescope. You want to find out all the details on Venus. You want to see it. It's a ping pong ball, ladies and gentlemen. It has all the details of a ping pong ball. It is white, white, white. It is covered from side to side with clouds. It doesn't clear. Even here on this actual NASA photograph of the real planet from a space probe passing by, even in this case, they've turned up the contrast, I think, a bit. The truth is, there's just nothing to see there. So we were trying from the Earth to pry any secrets out of this planet that we possibly could. Not all of them were about the planet itself. Some of them were about its orbit around the sun. Mathematically, people were trying to predict if they really understood Venus's motion. We're keying in here on the laws of gravity and things like this gradually to understand the motions of the planets. You ought to be able to say when one of them will pass between you and the sun. And Johannes Kepler was making a number of predictions. They weren't quite right. They were getting closer for when it might happen. And the first time that we actually had somebody observe a transit of Venus was in 1639. There were a pair of observers in England who were able to see this, and by recording exactly where Venus was, we began to nail down the motions of the planets in the solar system. Now, another discovery of the telescopic era, 1761, this is Mikhail Lomonosov, a Russian astronomer. He discovers that Venus has an atmosphere. Now, how in the world did he do that in 1761? No space probes, no spectral instruments and things like that, not at this point. What he did was observe one of those transits. And when he observed it very, very carefully, as shown in some of his original drawings in the picture there, he could see a ring of light around the planet as it entered the disk of the sun. Not the darkness of the planet itself that no light passed through, but some kind of a vaporous outer layer around the planet that he concluded correctly was an atmosphere. So that's when we figured that out. This was interesting to me. Spectra through a large telescope, indeed the largest telescope in the world in 1932, revealed carbon dioxide in the atmosphere of Venus. starting to learn more. Turns out carbon dioxide is very important in the atmosphere. That's mostly what it is. But this was our first detection of it. It was the world's largest telescope, the 100-inch telescope at Mount Wilson, right here. Exactly. There was a time where the largest telescope in the world was right over there. And this was an epical discovery here where we start learning that Venus is not necessarily going to be a lot like the Earth. Clues started coming in, and the clues weren't especially welcome. Remember, they were looking at a ping pong ball, and your imagination can go wild, and it did. People were trying to imagine what the planet next door is going to be like, right? Well, here you got 1958. We have got a detection here, an observation using radio waves, microwaves, to see with the radiation, the heat radiation from Venus. This was one of the first times where we started really realizing, you know what, it is not Club Med over there. It's going to be very, very hot. And this really squished a whole bunch of science fiction authors. This 1959, you can read about the jungles of Venus, right? And the oceans that are hiding under those clouds. No, not so. And the more we learned about Venus, 1962, the very first space probe to ever visit another planet successfully was Mariner 2. That's 1962, our very first visit to another world. And then the very first pictures for Trivia Night at Red Lobster, ladies and gentlemen. What was the planet to have its photograph of its surface first transmitted? I know you're all going to leap up and say, Viking, 1976. No, not quite. 1975, the Russian Venera 9, or Soviet Venera 9, was the first view we ever had of another planet. And by now, sadly, we knew blazing hot, incredibly inhospitable temperatures on this planet. So we did lose that romantic notion. We know now it's a very angry ping pong ball. It is, however, still up there tonight in your evening sky, burning like a silver flame, as the song says, the beautiful and somewhat less mysterious planet Venus.
Well, thank you for that, Chris. We can all take a look at it tomorrow night. And
as soon as it's clear.
Think about, yeah, well, if it clears up.
If it clears.
Early June gloom is what I like to call it. Although there's an upper level low. This is not your normal June gloom. No. This is caused by a low pressure. Well, Venus was in the news back in March, actually. We always thought that Venus had to have a lot of volcanism, needed to have a lot of volcanoes, because there just weren't very many craters on the surface. That Magellan mission that went there did radar mapping of it. They shot radar down through the clouds. They were able to see what the surface looked like, and there just were very, very few impact craters, which made them go, well, this is weird. Does the entire thing get resurfaced all at once? And then it stays sort of normal for a while, doesn't do a lot, then the whole thing is resurfaced. I always thought that was a crazy idea, but that's what people used to think.
They did. I remember them saying
yeah,
so.
They used to think that back in the 80s and even the 90s. But then people came to their senses and thought, well, probably not. Maybe it behaves like other bodies in the solar system where you'll have volcanoes sort of going off more or less all the time. And there would probably be some happening even when we visited. Someone went back and looked at the data. And this is data from that Magellan mission. And what you're seeing is on the right-hand side, in the upper panel, A, that was taken in like April. The lower panel was taken in something like June. These were only a handful of months apart. And Magellan happened to reobserve the same part of the surface. The surface features changed. Somebody actually went and looked, and you can see there's one vent that's unchanged, but then there appears to be this new flow. The surface, the character of the surface, the quality of it looks different. It looks chunkier, basically. And in one of those vents there, it has even changed its shape. That lower vent now looks more like a peanut, whereas before it was rounder. So this is very strong evidence that there was volcanism, that a volcano was actually going off when we went and mapped it. So this is another reason I'm super excited by the Veritas mission, the missions that are going to be going to Venus and observe this. They'll have higher resolution and maybe see more flows. Who knows? So we'll have to wait for that and find out. Well, Vanessa is here to talk about, well, by request. So I did request that she take this on as the first topic you were going to talk about. And in our defense a little bit, I'm going to smack the microphone. You did say that you didn't want a big topic this month because you have telescopes to take care of, you have a lot of learning to do on the job, all these things. So in the future, we'll hear a little bit more science from Vanessa. But tonight, what did I convince you to talk about?
Well, let me start off with just showing you this pretty picture here. Well, this is today's APOD, which was the astronomy photo of the day, which was really good timing because in the background, yes, you have the moon and you have Jupiter up there at the top right, and Jupiter is just coming out of an occultation. But in the foreground is Lick Observatory, which is what I wanted to talk about today. So really good timing. Thank you for sending that to me also. So on the right side of the observatory there you see in the foreground is the big dome. That is their 32-inch or 36-inch refracting telescope. And on the other side you see a little dome. That is the 40-inch reflecting telescope that is still used for research. The little dome is the one that's used for research. It's kind of fun. So yeah, I am talking about Lick Observatory, which was built in 1888. So it's a pretty old observatory. And it was built with money from the landowner. He donated the money and the land to have the observatory built for, you know, legacy purposes. So he wanted to have a legacy that he left behind. That is James Lick. So like I said, they have two big telescopes in the main historic building, which is what you see there in the picture. So I was actually able to go up there and observe through the telescope right there. So that's the 40-inch 40-inch reflector, the nickel telescope, yes. So this telescope is really important. It's used a lot for research. It's not the most important telescope. You know, it's 40 inches across. It's not that big. But yeah. So the observatory, Lick Observatory, was given to UC Regents when it was first created. And in 1965, it was given over to UC Santa Cruz, which is where I went to school and where you went to school. And so at Santa Cruz, they're the ones that take over the daily activities of it, and that's important later. But it's not just UC Santa Cruz that uses it. It's UCLA, UC Berkeley. It's just used it for research generally. And when I went there, I was looking for supernovae. So we are following up on supernovae and looking how they progress in their day, in their life cycle. And that's really important for figuring out what kind of supernova they are and how far away it is, all those things. But that little dome is really small, but it's pretty big telescope for the size of the dome. It was originally for a 12-inch reflector, so that's why it's not that big of a dome. So when you look in here, it's kind of cramped. It's a little small in there. So yeah, you have to be really careful when you're moving things around, make sure that nobody's standing in the way. So yeah, this is the nickel telescope. So that is a small dome. But on the other side of the building, there is the 36-inch refractor. And these two telescopes, just by themselves, are very important. You know, there's a lot of history in this telescope. This telescope is really cool if you never had a chance to go see it. This is in, by the way, I didn't say, it's in San Jose on Mount Hamilton. So this telescope is massive. It's huge, 36 inches across. And it's not just like an instrument for looking up at the sky, it's also a monument. So the panels on it are redwood, and James Lick is actually buried underneath the telescope. One of the visits, I actually got to go underneath there to check it out. It was pretty cool.
Did your TA tell you the joke about the plastic flowers that are there?
No.
Well, a little joke that, I never did this, but one of my fellow TAs did. Turned to the undergraduates and said, if you ever major in astronomy, you have to come up here and replace those flowers. They were plastic flowers, of course. Nobody replaces them. But the undergraduate went, oh. Okay. And you can tell they're thinking, I don't want to be an astronomer.
Yeah.
That's okay. Once you graduate, you get a different job. And that's just for the undergrads, right?
Yeah, just the undergrads.
Yeah.
But the ghosts that are wandering around up there, because he's buried right there at the bottom of that pier. So crazy.
Yeah, they did actually tell me that. So that's interesting that you say that, because they told me, oh, yeah, somebody comes down here and replaces these flowers. So
they're plastic.
They did.
Yeah.
But they didn't tell me I had to do it, so that's okay.
Okay. They were kind.
Yeah. So this is a really cool telescope. It's beautiful. Also, the floor lifts up. So you don't have to walk around any stairs. The floor lifts, and then you can walk up to the telescope and look through. It's pretty cool. but I didn't get to look through it, but maybe one day. But that's okay. So yeah, this is just in the main historic building of the Lick Observatory. So there's a lot at the observatory. There's a whole mountain, as you can see here. There's the big dome. That's the Shane telescope. That's the one that's really important. I think we had a night up here where somebody was actually doing live imaging with that telescope. Was that the Shane?
Well, it might have been the Shane. I know that I've used the Shane, and my advisor, Raja, has used the Shane as well. And Shadow the Scientist, one of the programs he runs that our foundation has eavesdropped in as well. I know the Shane is one of the telescopes they use for that, so it's good fun.
Yeah, the Shane is a very important telescope. It's really good. It's really, well, it has a spectrograph on there that I know that they use very frequently for the supernovae on the team that I was on. Yeah. And then you see there's 6 domes here. The one on the right is a planetary. It's looking for supernovae. And then way off in the distance, or not supernovae, it's looking for exoplanets. It's searching the sky automatically, kind of just does it. And then on the back you have the automatic imaging telescope for supernovae. That one's for supernovae. And a bunch of other really historic telescopes that have been there for since the 1890s, I think, some of them, and then some of them from 1930s. So lots and lots of telescopes. So it's very important. And it was actually the first observatory that's fully staffed and permanent to be on a mountaintop, which is really important because all of the observatories that we know are on mountaintops, and that's because there's less atmosphere above you, so it's easier to see things out in space. And so this is this is the first observatory to be on top of a mountain. And you know, on mountaintops, it has a lot of pluses and minuses. You know, plus you can see better. Minus, there's a lot of nature. You're far away from cities and all that, which is actually sometimes a plus. But yeah, lots of trees, as you can see in the image there, and greenery. And here at the observatory, we have the same thing, of course. And you may have noticed it was really rainy the last couple of months. So all of that rain brings all of that green that you see both here and here, in both of these places. And the green brings flowers. Oh my gosh, we love the flowers, right? But it also brings fire. So in 2020, there was a really massive fire on Mount Hamilton, and it nearly destroyed the observatory up at Lick. So it became within, was 30 feet of the main historic building, that's where the 36-inch refractor is, and that's where the nickel telescope is, which is still actively used for research. And you can see in that last one, there was the APF. The planetary finder. So it was a really huge fire, so they're actively looking for ways to prevent that from happening again. One of the ways that they're trying to do that is with goats.
Yay.
Fire-eating goats. That's what they were calling them. So they're not actually eating fire, but they're eating the fuel that the fire feeds off of, so they're fire-eating goats. You may have noticed the title I had for this story was Star Grazers. I really wish that I could take credit for that pun. I can't, because that is the name of one of their fake goats that they named. So they were raising money through UC Santa Cruz, because they are the ones that actually run the Lick Observatory. So they had a fundraiser to bring goats up to the observatory. So their first goal was to get the communication tower cleared, and then it was the helipad so that they can get people out of there in case. And then they also, I think they actually made it to their last goal, which was to get a 5-acre buffer around the observatory. So that's great. And the reason Santa Cruz is kind of important in that is that they actually brought goats to UC Santa Cruz to kind of eat around all the fire, or all the extra plants and all that out around there. So it was just last year. I missed them by a year, so I didn't get to see them. It was too bad. But I was there during the 2020 fires, and it was really, really scary. This is what it looked like up at on one of the walks up there. So yeah, I am 100% for the goats because it was very scary. But just so we don't end on this doom and gloom thing, this is an image from the astronomers' quarters up at Lick Observatory. So happy.
Yeah.
Very nice.
Very nice. Thank you for that, Vanessa. By the way, a little background of why I made her talk about goats. Well, one, they're cool. But two, I want to get them here at Griffith Observatory in Griffith Park. Every year, a team of folks have to come up here with loud, gasoline-powered weed eaters. They walk up and down the steep hillsides. A goat would do that and be happy about it. So anyway, I brought this up to my boss at one point when I was first hired, and he laughed about it. And ever since then, has been printing out articles about goats. But little by little, it's catching on.
Yeah,
and
no,
Lick Observatory is
it'll happen.
leading the way. So Mark, if you're watching tonight, don't blame Vanessa, blame me.
I'll support it.
Yeah.
I want goats.
Yeah, but she's in support on my team. Yeah.
Wow, I'm on board
Goats.
for this.
Yeah.
Yeah, this sounds like fun.
I'm in for
Yeah.
it too.
It'll
Yeah.
be good. They just got rid of the pony rides down there. They could put a pen with goats and have goat milk and a petting zoo, and it would
Goat
be great.
cheese.
So, well, it is time for our sky report, I think. Patrick,
That's
what
right.
do we have to look at that's
Oh, what's in the sky?
coming up? What's in the sky?
Okay, well, let's do it. Okay, well, we talked about Venus, and of course, Chris talked about Venus, the brightest planet in the sky, and we're about 6 days away from the end of the month, so I'm just going to talk about what's going to happen next month. But we'll do a little bit of backtracking here. Here's a beautiful picture I took of Venus when it wasn't cloudy, and you can see it's easily visible as soon as the sun sets, and it's the first thing you see. And this was taken roughly about half an hour after sunset. Now, as the sky grows dark, and this picture was taken just about 2 weeks ago, you can begin to see what's behind Venus, and there's some stars behind it. What are those stars? Well, at that time, Venus happened to be on the eastern, or rather the western edge of Gemini, the twins, and it's marked by the heads of the twins marked by the bright stars Castor and Pollux. At that time, if you drew a line, imaginary line from Castor towards Pollux, you'll find the planet Mars. Now, since then, and at the beginning of June, Venus will no longer be where it is in this picture. In fact, it will be where Mars will be. So we see Castor and Pollux and Venus, and on the first day of June, and you can draw a line across, although you don't really need Castor and Pollux to find Venus because it's extraordinarily bright.
Yeah.
So
You need Venus to find Castor.
yeah, you can backtrack the other way around. So yeah. Where's Mars? Well, Mars hopped over to the next constellation, the faint constellation of Cancer the Crab. So Mars is quite far away at this point and is not very bright. It was bright when it was in opposition to us back in the early part, actually early this year, in late December of last year. All right, so we're going to just move on here and keeping in tune with Venus. Venus has been just kind of dominating the western sky, and on the 4th of June, it will reach the greatest elongation east of the sun. So what does that mean? That means it's at its maximum angular distance from the sun. So if you can draw a line or measure the angle between Venus and the center of the sun, you have a 45-degree separation. And after the 4th, that separation will decrease because Venus is actually going between the Earth, actually going to move in front of this, between Earth and the sun as it makes its arc across the sky there. So by the 15th, you can see Venus is a little bit lower in the sky if you watch at the same time. And it's also closing in on the planet Mars. By the end of the month, Venus is much lower and is closer to Mars. It's roughly about 3.5 degrees apart at the end of the month. Something worth seeing on June 21st is a beautiful configuration of the 3-day-old crescent moon and Venus and Mars. This is going to be a very beautiful sight if the sky is clear, and also a photo op. If you with your cell phone, you can take a beautiful picture of this configuration, and you can see the moon, Venus, and Mars forms a nice right-angle triangle. Now, June 21st is a special date because in the astronomical kind of calendar, it is the summer solstice, or the first day of summer here in the Northern Hemisphere. And that exact moment of the summer solstice occurs at 7:58 a.m. This is the moment where the sun reaches its farthest northern point on its annual path in the sky, or what we call the ecliptic. That's represented by that red line. And that line is where the sun travels along, and that's only caused by the fact that we go around the sun, so it appears that the sun travels around the sky along that path from one zodiacal constellation to another. That's happening on the 21st, and it also marks the first day, as I mentioned, of summer here in the Northern Hemisphere, where the northern pole of the Earth is tipped towards the sun, and our days are longer and the nights are shorter. And conversely, in the Southern Hemisphere, winter begins in earnest, where the southern polar axis of the Earth is tilted away, and so the days are shorter and the nights are longer. So that's a complete reversal there. Just a quick view of the sky from in the middle of June. We have constellations Leo and Virgo over in the southwest. They're typically constellations of the spring, but they're moving over to the western part of the sky. And then towards the south and southeast, Libra, Scorpius, and Sagittarius are all emerging and will take center stage in the southern sky as soon as the night wears on. Over in the southeast is the constellation Aquila the Eagle with its bright star Alta, and seeing that star in the southeast basically heralds the beginning of summer, or the summer is coming soon. Now, I'm just going to focus on one constellation, and that is Scorpius, and it contains a star that is called Antares, which is Chris's favorite star.
It is my favorite star of them all.
Yeah, so we're going to take a look.
It's a big deal.
So you're going to see this constellation rising in the evening to the early night. And we have an image taken, this was taken by Anthony Perkic out in the desert of Scorpius rising, and you can see the head of Scorpius and the red star Antares. It might be a little bit difficult to see the whole shape of it, but here's, if we draw lines between the stars, you can see most of the body of the Scorpion, except for its stinger, which is below the horizon. Now, Mars and Venus are in the evening sky. What about the other planets? Well, there are two morning planets. One is Saturn. It's in the constellation of Aquarius, the water bearer, which is a faint constellation. And low in the east is the brilliant planet Jupiter with Juno spacecraft going around it and unraveling its secrets. So those are worth looking for if you're up in the morning and you're on a morning hike. Look to the east and you can see the two largest gas giant planets in our solar system. A quick look at our moon phases this month. Full moon is on the 3rd. Last quarter is the 10th. Let's see, we have new moon on the 17th. And at the end of the month on the 28th is first quarter. So that's what we have for the outlook for June for everyone who's stargazers. So go out and enjoy.
Yeah, a lot going on out there and plenty to see. So good fun. Well, now is when we normally would turn and join Katie Flynn with pretty pictures and some solar system weather. But she requested to move back to her primary production role, so she still has involved with the show. But by request, she didn't want to participate in the performance aspect right now, but she has put together a video for us to take a look at some beautiful pictures. It's a few minutes long, so if you're here in the audience with us here at Griffith Observatory, feel free to stand up, stretch your legs, do what you need. If you're at home, enjoy the video, and we'll be right back in just a few minutes. Well, those were some beautiful astronomical images,
Yes, they
and I
were.
do want to thank all the astrophotographers out there that are sending us beautiful images. I saw Blake's name up there, Blake Estes, who is a former employee of ours who headed off to Australia, and he regularly battles kangaroos now. So, okay, not quite, but still, he gets some fantastic images of the southern skies. Well, now it is time to talk about some rockets and some stuff that's been happening up there in space, and go out to launch with Jared Head.
Yeah, and I figured this time let's kind of cover everything that we can, because last time we had to, we focused a bit on Starship, flying and the bit of a boom that it had at the end of its tumble with that. So let's kind of go around the world and take a look, because we actually did have a significant number of launches from a wide spectrum of providers. So one of them is from the India Space Research Organization with their Polar Satellite Launch Vehicle on April 22nd, 2023. And it's just so cool to see how different countries do their own flights.
2, 1, 0.
So this was carrying Telios 2. So this was a communications satellite for Singapore. And this is it after riding on that fourth stage, heading up and getting a good separation on it. So it was successfully delivered to its orbit up in geosynchronous orbit. So that was, low Earth orbit, which was really, really cool with that. It'll study here on the Earth. Now, a rather big one that happened this month, we do still talk about SpaceX, where they actually had a fully expendable Falcon Heavy. So this payload they were carrying for the Viasat group actually completely, they didn't reuse any part of the Falcon Heavy except for the fairings. They expended everything. They burnt it to depletion of fuel and got maximum performance out of it. So the reason that they fully expended the Falcon Heavy was to put Viasat 3 into near geosynchronous orbit. So they didn't do what we typically call a transfer orbit. So we get you a little bit higher than geosynchronous orbit, and your low point is still close to the Earth. They actually had the second stage continue up to near geosynchronous orbit and then fire the engine again. There's those boosters separating at about 4,000 kilometers an hour faster than usual. And then also the first stage shut down at about 7,000 kilometers an hour faster than usual. So it was really, really pushing the power here with what it could do. And then a great view from the second stage there of that beautiful curvature of the Earth. And in taking that second stage up to near geosynchronous orbit and burning it there, and putting the satellite into that very close to geosynchronous orbit, it extends the life of the satellite and also gets Viasat 3 into orbit sooner so they can get operations started earlier. And there's the Earth from stage 2 as they were getting ready to fire the engine again. And then they had a great view of that separation of the satellite as the Earth appears again. Just kind of reminding you where it came from. So, and then a very cool thing that SpaceX did share with us was this view from the payload fairing coming back through the atmosphere, traveling at Mach 15. So what you're seeing here are the superheated gases building up on the fairing and essentially coming around it as it's on entry. So this is Maverick only got up to Mach 10, so this did Mach 15, so it was 5 faster than Maverick.
Could you roast a marshmallow in that, you think?
Yeah, I'm fairly confident you could. I don't know if the marshmallow would make it, honestly, but we could give it a try. So we could see some thermal loading there and figure out how marshmallows can do at Mach 15. Yeah. So I would be interested in that for sure. And then just a little bit further down the line on May 5th there, we had, I think, maybe one of my favorite names Rocket Lab has ever come up with for a mission, Rocket Like a Hurricane.
That's pretty good.
Because this mission was launching Tropics, which is going to be studying cyclones and hurricanes here on Earth. By the way, they're about 25 minutes away from launching the second pair in this mission, which the name for the mission that's going to be launching in just about 25 minutes, they're calling it Coming to a Storm Near You. So they've got really good, really funny names for themselves and their missions. And I hats off to the people who named them. But they also have a beautiful launch site at the Mahia Peninsula in
10,
New Zealand.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Now there's tons of sheep running away from the launch site, but that's just a really cool rocket. All that carbon fiber, it looks so beautiful. And then I always love staging on the Rocket Lab Electron rockets because it's always moving a lot because it's a very, very small rocket. It only carries about a couple 100 pounds into Earth orbit, so it's not a big rocket. So when the engine starts up, it moves around quite significantly. Then we go to China, where China is keeping their space station supplied with the Tianzhou 6 mission. This was launching on a Long March 7 rocket. There it goes. Now that Tianzhou 6 supply ship is very capable. China is very capable with their rocket, with their aerospace industry. And here's the separation of those boosters coming off of the rocket. So much like the United States, where we can, if we wanted to, or Russia, where they do with their Progress vehicles, China was able to get their Tianzhou spacecraft, their cargo resupply spacecraft here, to rendezvous with the Tiangong 1 space station within one orbit. So it only took it 93 minutes for it to get there. And that is an incredible capability. I mean, just there's only 3 countries that could do it: the U.S., Russia, and China. And this is not something brand new either. They've actually done the one orbit rendezvous before. But here's what docking looks like. And that is at real speed. They do dock a little bit faster than everybody else does, which is always a little unnerving to watch. But hey, if it works, it works. So they do have 3 astronauts on board.
Are they still delivering rocket parts to villages after every launch?
Oh, yes, absolutely. China sort of has, in case you may not know, China has this this sort of, I don't want to call it no safety policy, but essentially the rocket part drops where it drops. So it would be like if we launched a equatorial launch out of Vandenberg near Santa Barbara out there, and then said, well, if the first stage lands in Anaheim, big deal. So you'll often see after these launches rocket parts that are like in villages, or it's like near a village and a whole bunch of people are standing around it as the orange smoke from the toxic hydrazine propellants is coming up right around the people. So yeah, it's just overall it's not good. But I can tell you that one of the things that the China National Space Administration is doing with their designs is they are moving away from the toxic propellants.
Oh, good.
And they are also developing, they want to have reusable rockets, just like SpaceX's Falcon 9. And they're developing their own reusable rockets. They've actually tested grid fins on a couple of those in order to actually aim those first stages to appropriate places.
I thought you meant aim for the villages.
Maybe they might. I mean, it makes a good tank, but I'm not sure. If you could store anything after the tank hits the ground with that there. So yeah, it can be a bit of a problem. And then also, we had our second private crew head up to the International Space Station on May 21st, the Axiom 2 mission. Their commander, Peggy Whitson, is a NASA veteran astronaut, former commander of the International Space Station itself. We also had our pilot, John Schaffner, who actually is a businessman, but he has a lot of experience driving race cars in the 24 hours of the Nürburgring. And I know we kind of giggle a little bit about that, but he also does have a couple thousand hours of flying aircraft. And I'm not talking like little Cessnas and things. He actually owns a P-47. So for those of you who are who really like World War II aircraft, you'll know that that's not an easy plane to fly whatsoever. However, what's so cool about this mission is that on Axiom 2, our two mission specialists, Ali Al-Korni and Rihanna Barnawi, those two mission specialists are from Saudi Arabia. And in fact, Rihanna is the first woman from Saudi Arabia to go to space. So they are up there on behalf of Saudi Arabia performing commercial tasks right now, doing research, and they are busy. So they are not, it's important to note that this is not like previous flights where tourists have gone up and then kind of just hung around the space station for 2 weeks. On the Axiom 1 and now the Axiom 2 mission, these people are working. Like, they have stuff to do, and they are paying to do that. So they very much have that motivation to get their stuff done. And from what I understand, they are. So doing very good. Almost a week into their 2-week mission, everything's going just fine for them. And then we have a Russian resupply with the Progress vehicle yesterday. And who doesn't love a good Soyuz launch? I mean, it's a classic rocket. It's like a Ford Mustang Shelby of rockets.
Yeah.
So.
Yeah.
I thought you were going to say Ford Pinto, and I thought
I was
that's
gonna
not
say,
quite right.
Yeah, I wouldn't hit that from behind.
No.
I wouldn't rear end it
No.
at all. That would be a very bad idea. But like I said, the Russian resupply craft, the Progress, only takes one orbit to get to the International Space Station. And these are some views from the camera that's on board of Progress. This has been sped up. This is a time lapse. It doesn't come up on the space station this fast. But it's just really cool that we actually get to see these kinds of cameras in real time. And then also, I love that Russia, like Terminator style, just puts all the data on the screen that you're watching through. And here's docking itself.
Contact. And capture confirmed. Docking confirmed.
And it's just that simple, right? Piece of cake. Now, it's sort of keeping with NASA here. You'll notice that this is the Space Launch System rocket that was used for the Artemis 1 mission. And it's sideways, which is typically not how we want rockets to be. I think Starship Super Heavy showed what happens when rockets go sideways. Not good things. But what we're looking at here is actually an engineering camera. So this right here is what folks like myself, who are aerospace engineers, really care about. We're not so much interested in looking at NASA's feed or other things like that. I'm much more interested in this because this is going to allow me to look at the real details here. So I want you to take a look at some of these things. It is going to be in slow motion here. By the way, this was recently released thanks to a Freedom of Information Act request from somebody on Twitter. Basically went at NASA and said, hey, can we have the footage? And NASA said, sure, it's yours. So you can actually now go online and download this footage in 4K if you would like to, and it is glorious. So one of the things I really like here is that once the solids light, you'll actually see the air, you'll see that blast from the air, the concussive wave of the solids igniting, boom, right there. And then you also see a couple more as they're coming off of the pad right there. So absolutely beautiful footage with it. And it's sideways here because this allows us to see the rocket in greater detail, higher resolution than we did if we would have it vertical in the frame. So a lot of people are like, well, boy, did they mess up on shooting this. Well, no, again, we as engineers, we want as much detail as we can possibly get. So that's the whole idea. So that's why you'll see a lot of these. And there's a nice little close-up area showing those two solids and the 4 RS-25 engines Those poor RS-25 engines. I
That
know.
belongs in a museum.
Yes, it does. Those are what was used as the Space Shuttle main engine. Those are former Space Shuttle main engines going to a watery grave, and I feel so bad for them because every time I think about it, I just think about the engine shutting down and going, okay, we're coming back, right? Okay, why is it getting hot all of a sudden? So I always feel really bad for the engines. Now, this was very interesting. For some reason, this rocket from South Korea had completely come under my radar and has already done 3 launches, but this was its first commercial launch called Nuri. So this was fantastic to see this. You know, another small satellite launch vehicle, so entering the market. So now you're getting even more options for what you'd like to do. And here it is deploying that small satellite that maybe weighed a couple 100 pounds and was about the size of our video cart, so maybe 4 feet across with that there. So not a big rocket, but it was a success. Its first commercial mission had a success, so great for them. So that was actually earlier today, and also earlier this morning, Virgin Galactic returned to flight with the Unity 25 mission. So they dropped VSS Unity 25 with 4 employees of Virgin Galactic. So I guess if you go work at Virgin Galactic, you got a chance at going to space. But they lit that engine, and then Spaceship 2 put itself into the vertical and headed for the skies, and was able to top out at an altitude of 87.5 kilometers. And as far as many people are concerned, close enough to space. So there you go. We had some folks get that experience today. So just kind of cool. So this is from what I understand, the final test flight of Virgin Galactic Spaceship 2. After this, it will now be commercial customers or paying individuals that will be going on this flight. These flights. So you see that the wings come up, and that's actually a part of the system that has it come down. It keeps it stable as it's coming through the atmosphere. They really only get up to about 3 times the speed of sound, so not really something that's going to heat up too much where you need a heat shield. But yeah, pretty impressive, and I would be at the window the entire time if that were me. And then, of course, we want to let you know your launches with an orbital velocity out of our local Space Force base, Vandenberg, where you can go watch some things on May 31st at 10:27 p.m. or 22:27. SpaceX will be launching a Starlink flight, Starlink 2-10. And then on June 8th, thought to be sometime around 1 o'clock or 1300 hours, Transporter 8 will be launched. This is a series of missions that have a whole bunch of small satellites on board. We'll deploy them, and you can pay them to do that for you. And I've got the 3 stars there for the 3 sonic booms that you hear from a first stage of a Falcon 9 returning to the launch site, because for Transporter 8, you should have the first stage of the Falcon returning to LZ4, or Landing Zone 4, which is the one that they have out at Vandenberg. So if you can, highly recommend, if you're planning on going to work that day, maybe call in sick and go out to Vandenberg. And
he says, with his boss sitting right there.
Yeah.
Dude.
Yeah.
That's because I won't go. I'm sorry. I'm not gonna be here, unfortunately. But yeah, that's where if you ever wanted to catch one, there's your chance. Also, we got another Starlink launch happening sometime in June, and then a very interesting one, no earlier than June, is from TACRIS 3 from Firefly with their Alpha launch vehicle. This is actually a tactical response mission. So basically, the Space Force contacts Firefly Aerospace and says, hey, you have a rocket currently on site at Vandenberg. We have payloads. You have 24 hours to load the payloads and launch. So so that's a bit of a test, and we'll see how well Firefly can do that. So that is essentially you're out to launch.
Well, thank you for that, Jared. I appreciate that update on all things space. Awesome. Well, we're going to turn our attention back to our solar system briefly before we're going to head out to deep space. I'm going to give you a little Mars update. Some amazing things have been happening on Mars, and this is, of course, one of our 2 rovers that is cruising around on Mars. This is an illustration of Perseverance. And here are some tracks that were left by Perseverance. And you might notice it looks like it dropped a lightsaber there behind it itself. That is not a lightsaber. Those are actually the samples. Those are it's dropping the samples to be later picked up and returned to Earth. So the cores it took, it's been dropping them, and it did that successfully. They've mapped out where all of those are, and now they've got to go pick them up and get them back to Earth and bring them to labs. So we can
a fun scavenger hunt.
Exactly, a very fun scavenger hunt. But I do like how they look like lightsabers. It is still taking more samples. There are more sample containers, and this is another rock that was interesting enough for it to drill into and get another sample successfully. Right now, Perseverance is by a rather large crater called Belva that is where it is, as is the little helicopter, Ingenuity. I have a hard time believing they have been on Mars 804 sols, which are Martian days, which are not much different than our own day. So it's been about 800 days. Crazy, but time flies. Here is the beautiful Jezero crater, I think is how it's said. And you can notice in the left-hand side there is a deposit that came in. This is a delta that we think the river was flowing into a lake, leaving the material behind. That's why we wanted to go there. And indeed, you can see the Delta Scarp, Octavia E. Butler landing site. Of course, she was a science fiction writer, author, and they named the landing site after her there. And you can see that crater over on the left-hand side that looks like it has some sand dunes in it. That indeed is where Perseverance is right now. And that is the shot of that crater in the panorama there, looking down into it. Now, Perseverance has been seeing some interesting features. You can see these sort of curving rock structures that are there. It's believed that these formed in a fast-flowing river. So one of the fastest flowing rivers that we've seen evidence for on Mars, of course this was billions of years ago, can leave these sorts of structures behind, either evidence of a sandbar that was knocked down in there, or perhaps even edges to the river are being seen, not these particular features. I noticed that while I was looking at this, there was an odd-looking rock. And when I zoomed in on it, it didn't look like the other rocks. It looked kind of metallic to me. And it might be a meteorite. I don't know. Call it Reitzel's Rock, NASA. You hear me?
They have found meteorites out there. I mean, this is not impossible.
Yeah, we found quite a few. In fact, more than we thought we would. Curiosity was finding them, just driving along, and it would find an iron meteorite just lying there. And part of it is they don't erode like they do on Earth. They don't get covered by things. Well, they don't really go away. They'll get rusty here on Earth. But on Mars, there's just, for some reason, they're hanging out on the surface a lot more, easy to find. So I am curious if that's one to know.
Better than that than a beer can. Just sitting out there.
Well, I might write to our friend Nikki Cox and see if she knows anything about this, and have the team take a look. Be like, send it back over there and analyze it. Of course, the helicopter, like I mentioned, took its 50th flight. So 50 flights on Mars for a test helicopter. It was supposed to do like 5 flights or something, some small number.
Insane.
Just absolutely crazy. Here's a shot from the air. The flights keep getting longer, higher, faster than before. And you can see that bright spot with a dark shadow. That's the shadow of the helicopter itself. You can see the little round things in sort of the middle upper part, the middle upper third of it. You can see a round thing. So those are the legs of the helicopter, believe it or not. And that bright spot is the sunshine, which coherently reflects off the surface a little bit. But there's something else in this picture. Does anybody see it in the upper left of the image? For those in our audience here, I can point it out with our laser. It's in the very upper left corner. That is Perseverance. And there it is. Now, this camera on the helicopter, of course, is not exactly a 4K, super high quality. It was meant as a test helicopter to fly around. But it's still doing scouting for Perseverance, still looking around. So very successful and super cool. Here is some beautiful clouds that Perseverance picked up, just drifting over the crater. There are water clouds up in Mars's sky, and this was probably taken sometime close to dusk or dawn, and Mars's sky kind of gets this bluish color, which is interesting. Unlike our red sunsets, Mars's sky is normally red and has bluish sunsets. It's kind of appropriate. Now, not to be left out, Curiosity did get this beautiful picture of a feather-like cloud up in the sky, which is just really pretty neat looking. And then also saw this crazy, almost book-like rock. Now, keep in mind the atmosphere of Mars is about 1% of what Earth's is. So even when the wind is blowing, you don't have a lot of pressure behind it. You don't have things that can knock things over. So strange, delicate-looking structures can kind of last longer than you'd expect them to. So some odd mineral features that it's seeing. They call this a book-like structure. Another thing that happened on Mars, the United Arab Emirates has a small satellite at Mars called HOPE, and it took this image of Deimos, Mars's smaller moon. It orbits Mars about every 30 hours, so it takes a little over a day to go around it. We had never gotten a very close-up picture of it. We had seen them before, but we always thought that Deimos and Phobos were probably captured asteroids. It made sense to us. Mars, and then the asteroid belt is just beyond that. They're small. It's just kind of what we went with. I often wondered, well, how does little Mars capture an asteroid? It's not exactly Jupiter, very big, but okay. Turns out that might not be the case with Deimos. The surface of it has the same chemical composition as Mars. It doesn't have the chemical composition of an asteroid. So what's going on there? Did something smash into Mars, blowing material off that later reaccreted and formed a little moon? Did they form together? Seems unlikely to me. I don't know, but super, super interesting, and it's great seeing a little mission like the HOPE mission from the United Arab Emirates make a discovery like this. It's, everybody can get involved in space and science. It's a lot of fun. All right, well, I think we are finally time to turn to deep space. Do we have our guest from afar here? Sarah, are you out there? We'll see what happens here.
Well, it takes time for the signal to get out to her.
The signal has to get out there, exactly.
She's in deep space.
I am.
There you are. Hello, hello.
Hello, calling through the DSN.
Yes. Sarah is another one of our producers on the show and also another wonderful museum guide. And she said, this show needs something else. It's just all this solar system stuff. Who cares? Why should I care about it? Okay, she didn't say that. I'm putting words in her mouth. But we agreed that, well, how about we throw in a little morsel of some deep space stuff just to round out the show. You've heard a lot about Mars and Venus and Jupiter. So, Sarah, do you have a little bit of deep space stuff for us to finish out the evening?
I do. I do indeed.
Excellent.
All right. Here we go. Okay, so MIT observed a black hole eating a star. They found this in NEOWISE data, and it is the closest to us we've ever observed this kind of event, a mere 137 million light years. So it was found using a technique that skims through survey data. So that means we may be seeing more findings in old data like this going forward. So I look forward to that. We go to the next image. Oh, yeah. All right. So we've got a supernova found in the Pinwheel Galaxy. So as you can see right there, SN 2023. So we saw this image earlier in Pretty Pictures, but it was so cool. We wanted to give you a little bit more information. So this supernova was discovered on May 19th. And from the spectrum, it's looking like this was a type 2 supernova. So what you're seeing there and what we can see here, you can see that dot flashing. That is the core collapse end of a massive star. All right. Now, enough of that other stuff. Back to JWST, because... All right, I kid. Now, JWST has given us the most detailed look at the protoplanetary disk around a star called Fomalhaut. It's up to you. I leave it to you how you want to pronounce it. But you can see off to the right, there's sort of a knot, a brightening in the disk. That may be a planet being formed, but don't get attached. In 2004, Hubble showed us a similar bright patch in Fomalhaut's disk. And by 2014, it had dissipated. So, yes, this might be a planet. but it might still get smashed. And speaking of smashing, we've got colliding baby galaxies for you. So these are from the early universe. You can see in block JD1, there are two little blobs. One of those is one of the galaxies, the other one's the other galaxy. And together, they're about 13 billion years old, making them the earliest examples of colliding galaxies that we have found to date. And also, block JD2 and block JD3, they're the same pair of colliding galaxies. So we've got 3 different images of that same colliding galaxy pair. What's happening is gravitational lensing. So you've got a distant object, that galaxy off in the far left, and that light on its way to us, it passes through or near something massive, and the gravitational field, the forces of that matter sitting in space, warps the light on its way to us. And so instead of getting one image of that distant galaxy, we get multiple images spread across our sky. So fun times with JWST. And allow me to introduce to you exoplanet GJ, 486b. This is a bit of a cliffhanger for us. So JWST took some data of the atmosphere of this exoplanet. What you have here on the right-hand side, that is water detection. We have a positive detection of water vapor, not water liquid, but water vapor. Now, we've got 2 possible sources for that water vapor. We've got the blue line, and that blue squiggle, that is what the data would look like, the path it would take if the water vapor is from the exoplanet's atmosphere. And if it is from the exoplanet's atmosphere, that would be the first time we have detected water vapor in an exoplanet's atmosphere. But that yellow squiggle is the path that the data would take if the water vapor is from the star spot, or a spot on the star behind. Yes, star spots have water vapor in them, even in our own star. So you can see that where we've got the white bars, the data on the right-hand side, the yellow squiggle and the blue squiggle are basically overlaid. They are indistinguishable. So what we need is to fill in the left-hand side. Unfortunately, that means we need to use a different instrument. Luckily, it's also on board JWST. So we need to turn to the nearest instrument, or near-infrared imager and slitless spectrograph. That's a mouthful, don't worry about it. But the next time we have the right situation for observing, we hopefully will be able to fill in the shorter wavelengths on the left side of that spectrum and figure out if the water is coming from the star or the planet. And you may be asking yourself, why is it so hard for us to tell the difference between a star and a planet? Here is why. To get this data, we need the light from the star to pass through the atmosphere of the exoplanet. So we're not looking at the fingerprint of the star. We're looking at the fingerprint of the star and the planet overlaid in the same bit of light. And we have to separate them out to figure out which one we're looking at. Okay, so we're going to keep watching this. Hopefully there will be more data for us soon. And now, even more pretty pictures, because I couldn't help myself. We have Cassiopeia A, a supernova remnant. We have ARP 220, another set of colliding galaxies, and they are so bright that they're acting like a point source and giving us the pretty diffraction spikes that we have come to love from JWST images. And they got ambitious. They've given us JWST plus Chandra data. So we've got infrared images with X-ray images overlaid. So let's take a look at those. We have NGC 346, which is a star cluster in the Small Magellanic Cloud. We have NGC 1672, which is a barred spiral in the constellation Dorado. We have the Eagle Nebula, M16, everyone's favorite, and the Phantom Galaxy, M74. All right.
Well, thank you for that deep space report. Oh, you fast forwarded us to our credits, Sarah.
Sorry.
Thank you for that report on deep space. Appreciate you rounding out the show and bringing us a little bit of fun at the end there. Always good to hear from you, Sarah, even though you're a little ways away from us. So nice to see you. Well, that finishes out our show for tonight, everybody. So thank you for joining us, to our online audience on YouTube. Thank you to our audience here at Griffith Observatory for joining us. Thank you for my fellow folks on the panel here, Vanessa, Chris, Patrick, and Jared. And we will be back next month, and I believe we will be on the third Thursday, unless we're not, like I said. So All Space Considered is brought to you by Griffith Observatory, which is owned and operated by the City of Los Angeles and the Department of Recreation and Parks. And as always, we like to thank Griffith Observatory Foundation, our exclusive nonprofit partner. We thank all the individuals that donate to make things possible, and also the grant funders that help us out with our various programs. So thanks to all of those. And just thanks to all of you out there that join us every month. We do this for you, and we'll see you again next month. Good night.